Good morning, Year 10. Welcome to this summer term. I hope you're all safe and well. We're going to start a brand new topic today called C4 Chemical Calculations, and there is a workbook to work through, but please do not print the workbook off unless you really want to. Just simply doing it on paper will suffice, and you can then take a photo of all you're working out and upload it to the assignment for proof that you've actually done it. So I'm just going to go through the workbook and explain what I want you to do this week. So let me just minimize the screen. So you can see there's quite a lot of activities to get on with here, from relative masses, using moles, reacting mass calculations, and I will produce sort of like teacher walkthroughs for each of those, including the one today. So all I want you to do this week is the relative masses 1 to 4. So 1, 2, 3, 4. It's 4 worksheets. So I'll show you what they actually look like. It's like half a page per worksheet if you like. So it's this, that, and then, all right, these two as well. So if I just click on that. Relative mass is 3, relative mass is 4, and then also relative masses 1 and 2 on the previous page. And I'll go through bits and pieces of them now to explain how to do it. Okay, so if we go into the actual assignment, so if we go into the whiteboard, so the first task is relative masses 1. Nice and straightforward task this. You're basically going to have to convert all of these tiger, gorilla, these different animals. They weigh, they have a mass of various different kilograms. So 40,000 kilograms for the sperm whale, going back to 0.4 grams for the worm. What I want you to do is, rather than just state those masses in kilograms, I want you to give me what do they actually weigh in teenage girls. So, for example, first one's been done for you, the tiger. The tiger weighs 200 kilograms. The teenage girl weighs 50 kilograms. So 200 divided by 50, that equals 4 teenage girls, effectively. So you could say the tiger weighs 200 kilograms, or you could say it weighs 4 teenage girls. So I just want you to go through all of those. It's fairly straightforward. Do the mass in kilograms divided by the 50 kilogram mass of the teenage girl. So I'll just do one randomly down here for you. So let's look at the dog. So the dog would be 30 kilograms divided by the mass of a teenage girl, which is 50 kilograms, and that equals 0.6. So a dog weighs 0.6 teenage girls. Just be careful when you get down to the last couple. So if I just highlight those for you here, okay, their masses are in grams, not kilograms. So just to make sure you're aware how to do that, to convert grams into kilograms, so grams into kilograms, you have to divide by 1,000. Ignore that message. There we go. Divide by 1,000. Yeah, and then once you divide, so you take these, divide them by 1,000, then divide them by 50, and it will give you the right answer. So that's the first part of this worksheet. The second part is calculating masses of compounds. So you can work out the masses of elements just simply by looking at their top number on the periodic table. So these are basically the masses of all these different, there we go, go away, error message. So these are the masses of all the different elements that you'll need for this worksheet. So you don't actually need a periodic table for this. And I'll just show you how to briefly go about calculating the masses of compounds. So these are just individual atoms. You need to work out the mass of compounds. First one's been done for you. So let's just figure out how did they work out that NH3 has an MR, and MR just means relative molecular mass, okay, of 17. So you take the formula, which is NH3, and then you just write down basically a list of all the different elements that are in it. So you've got 1 nitrogen atom and 3 hydrogen atoms. I will then go to my table here and find where nitrogen is. So nitrogen weighs 14, hydrogen weighs 1. So I'm going to just write 14 and 1. And then it's 1 times 14 is 14, 3 times 1 is 3. So that whole thing weighs 17. All right, so that's how the 17 came from. Let's try the second one then. I'll try and do this on the line just here. So N2H4 Just zoom in a bit more. There we go. So N2H4 has got 2 lots of nitrogen atoms and 4 lots of hydrogen atoms. And then using the numbers at the top, it's the same again. So nitrogen weighs 14, hydrogen weighs 1. 2 times 14 is 28. 4 times 1 is 4. So then if I add 28 and 4 together, it will give me the correct answer of 32. Yeah, so there's quite a few to be getting on with here, and on relative masses 3 and 4. I'll just show you another more tricky one. So let's look at G, for example. So G's got brackets in it. So what do we do with this then? Well, do exactly the same as we've done before. Okay. So we've got 1 magnesium, and then in brackets, whatever when we've got brackets, we've got to times what's ever inside the bracket by what the little number is outside. So there we've got 1O. So we've got 1O in the bracket, but there's 2 lots of it. So it's 2 times 1, which is 2. So there's 2 O's in total, and it's the same for the H's. See, we've got 1 H just there, but because there's a little number 2 after the brackets, there's 2 H's in total. So then if I go to the top and find where these elements are, so I need magnesium, which is there. Just get that out of the way. So I need magnesium, which is that, oxygen, which is there, and hydrogen, which is there. So I've got the numbers there. So magnesium's 24, oxygen's 16, hydrogen's 1. Okay, so 1 times 24 is 24, 2 times 16 is 32, and 2 times 1 is 2. And then the same again, if I add that number, and that number together, it should give me the correct answer, which I believe is 58. Okay, so that's what you need to do with that first activity. The second part is a little bit trickier. So it's about working out the MRs, which is the mass of a compound. So all the different atoms in it added together, their mass numbers added together. Sorry about this error message keeps popping up. All right. This time we're asked to work out the percentage of a particular element in the following substances. So it's the same thing again, and you'll be able to, you need to work out the MR first. So let's just show you an example. Let's do C, for example. Okay, so let's use C. So I'm asked to work out how much potassium there is in potassium hydrogen carbonate. So what I'll do is I'll do a bit of working over here. So KHCO3. So let's just work that out. We've got 1K, 1H, 1C, 3 O's. And then finally the mass numbers from the top. Potassium is 39, hydrogen's 1, carbon's 12, oxygen's 16. So then let's add all these together. 1 times 39 is 39, 1 times 1 is 1, 1 times 12 is 12, 3 times 16 is 48. So let's add those numbers together to work out what the total mass is. 40, it is 100. It's a very nice number for us. So the whole thing has a mass of 100. All right, so think of it as like a pizza or a pie or a cake. The whole cake, pie or pizza weighs 100. We're asked to work out what percentage of that is potassium. So how to work that out is find potassium in your calculations here. So it's just there. So of that 100, how much was from potassium? Well, it says 39 there. So the calculation would be 39 divided by 100 and then times it by 100 to get it into a percentage. So it's 39 divided by 100, which equals 39%. Yep, and just work through all of those to do that. When you get onto the second worksheet, okay, it's very much standard thing as well. Some of these in there in particular you will have calculated on the previous worksheet. So don't write them out again. Just just write down the answers next to it. And then there's a separate set for you to another set for you to get on with just here. So I will release the mark scheme for this lesson on Thursday. So you've got until Thursday to give it a go. You can use Thursday's lessons to mark and polish your work, and then upload all your your polished work, so with all your calculations, into the classroom, into the assignment for next Monday, which is the 27th of April. And if you've got any issues, as always, please do email me. All right, enjoy.